Hi, I'm Simon.
I'm Lucas.
Our presentation was on testing Scylla on production.
Yeah, we simply put Scylla test server in our production traffic just to see how it performs.
We want to tell you the story of our adventure with Scylla database and how we came to the conclusion that we can save a lot of time and a lot of money just by replacing Cassandra with Scylla. My name is Simon. I'm a systems administrator. This is Lucas, database administrator. We work for Allegro, where we are part of 7-person team supporting NoSQL databases. Let's take a look at the agenda. A few words about our company, what we do, how we use Cassandra, what we use Cassandra for, and our infrastructure. Then we'll take a look at common problems, the tests we did, and the results. And finally, hardware reduction plan. This is something we came up after reviewing the results.
Okay. Some background about our company. Allegro has started about 17 years ago, and it started as auction site. Now it's the biggest e-commerce company in Poland and one of the biggest in Europe. And maybe some number about Allegro. About 14 million users is doing shopping, do the shopping using our site, and they sell or buy 750,000 items daily. Our site has about 200 million views per month. Okay, let's take a look at Cassandra at Allegro. We started using Cassandra about 4 years ago. Our first cluster was deployed on a bare metal machine, and it was shared cluster. It means that there were a lot of key spaces, a lot of schemas, and a lot of microservices connected to this cluster. And because of some problems with big partition or too many tombstones, you know, when one table has some performance problem, it degrades entire cluster. So we switched to Linux containers, and now we deploy all our clusters using this technology. We also use audit log in Allegro. It is because some regulation in our company, and Cassandra is used in many areas in Allegro, in financials, recommendations, and it is storage for our monitoring tools. And some numbers, we have installed 20 clusters on 250 nodes. Our peak traffic is about 250,000 operations per second. Most of the traffic is a read traffic. About 20% is write traffic. We've got clusters in size from 8 to 44 nodes, and we've got SLA in our company. That means that our cluster have to respond in time no longer than 100 milliseconds. I know it's a pretty big number, but we know that we can lower this number switching to Scylla.
A few words about the infrastructure we use. We use 2 data centers, and because the majority of our microservices run in active mode, Scylla and Cassandra fits perfectly. Every our container has dedicated hardware resources, and they are allocated exclusively. That means there is no sharing, no over-provisioning, and that's how we do it. Our Cassandra and Scylla node has between 8 and 12 virtual CPUs, 32 gigs of RAM, and 1 SSD drive. The only thing shared between containers in a single physical machine is 10 gigabit network connection. We know that this is below what Scylla recommends for production, but we wanted to replace Cassandra with Scylla on exactly the same hardware and see how it performs software. We run Cassandra 2.1 on Ubuntu servers. Java version is 1.8, and we use G1 garbage collector. And the heap size varies between 10 and 16 gigs of memory. For deployment, we use Puppet. Our backup solution is based on rsync. As for monitoring, we use standard tools like Graphite and Grafana. We also have a bunch of scripts that alert us if there are problems with tombstones, big partitions, or any other possible problems. PagerDuty for notifications, and there is also our health check tool called Cassandra Pinger. This one constantly queries the clusters, all our clusters, at a low rate, and alerts us if there is something wrong with the whole cluster or with a single node in a cluster. Clusters, speaking of clusters, because of microservices we generally use one cluster per service. That's why we have a bunch of clusters. Compaction strategies, we basically use all of them. The only exception is date-time compaction strategy. Minimum cluster size is 4. We run full repairs periodically, and backups are run every 3 hours.
Okay. Now I will say about problems we met using Cassandra. The first one, I think many of you who is using Cassandra will know such screen. It's a chunk of our JVM log. It's of course garbage collector pauses. As you know, when one node of Cassandra have a GC pauses, it responds in very long time. Another thing or issue is slow time of maintenance task. We do a lot of operations such as adding nodes or removing nodes. We migrating some schema or some data between nodes, between clusters, and we do a lot of such operation, and it takes time. Of course, we've got some automation scripts, but it takes time. Another thing is Java tuning. We spent a lot of time trying to speed up, and the result is that we gain a few percent of performance because of latency spikes. We use, of course, speculative execution. And one of the things is documentation. We very often have to look into code or look into Jira's just to see how it works. So it leads us to one fact that latency matter. Our user expect from Allegro very fast response times, so we also need that our databases will respond very fast. And I think it was about 2 years ago we started looking for some solutions, some alternatives. And last year we attended Scylla Summit just to meet people, to talk with them, to share some experience. And after that time, we decide to install Scylla, try it, and we do some tests. And please, Simon.
Tests and results. Before I start, let me say that we did the test on exactly the same hardware. There were no difference in the number of cores nor memory. These were the same boxes. We divided the tests into 2 parts. The first one we called maintenance tasks performance, and by maintenance we mean things that we do quite often or needs to be done quite often. And we wanted to see how fast they go when you compare them to Cassandra. The second type of test is the best possible kind of test. We basically put Scylla in production and see how it performs. Okay, let's go to the first one. Maintenance tasks. Here is the setup we use. 6 nodes and 6 nodes, every node loaded with around 300 gigs of data. We started with repairs. Repair time in minutes. You can see that Scylla performs twice as fast as Cassandra. The time is much better, so it's faster than 2 times. When it comes to decommissioning time, the difference is huge. Half an hour for Scylla against over 3 hours for Cassandra. I should mention that we waited for compactions to be finished, because even if the node is decommissioned, the compactions on the remaining nodes are still working, slowing down the whole cluster. What else we've got here? Cleanup times, 22 minutes against 33. And joining a new node, again, huge difference, 43 minutes against over 3 hours. The thing about those tests are, whatever we did, Scylla did it faster, and it wasn't 5 or 10%, it was hundreds of percent, and the response time from the Scylla cluster was always better. If you look at the response time of Scylla when it's under load, it's still a straight line. You cannot see those spikes. It just runs smoothly. Yes?
Okay. And the second part, as Simon said, we just put it our Cassandra, our test Scylla cluster, and Cassandra to our production traffic. On the bottom, there is our production cluster with Cassandra. We deployed 2 servers, 2 clusters. It is a 6-node Cassandra cluster, and the second one is 6-node Scylla cluster. They have the same hardware configuration, just to have good comparison in performance. On the right side of this diagram, there is Mesos instances with traffic, and all our clusters and application on Mesos sending metrics to our Grafana. And the results, I would like to say that every time we measure latency, we can see that on Cassandra there is a lot of spikes. And when you connect application to Scylla, it's very stable response time. What very important to us is percentile 99. It's usable in Scylla, and we noticed that it's up to 7 times lower response time in Cassandra. Next graph, as we said earlier, we use speculative execution. We have to do it because of spikes on Cassandra. As you can see, number of retries to Scylla is a few of them, and when you're using Cassandra, it's going hundreds. The second next graph shows CPU average. It's average from all our nodes, and you can see that Cassandra is using more CPU, and you've got bigger response times. On the right side, you can see that Cassandra CPU usage is going down. That because we have to simply redirect traffic from Cassandra to Scylla because of too high response times. Because this production traffic, we have to switch off Cassandra, and as you can see, Scylla was able to process traffic from Cassandra, and that our next 3 days we measure that our 6-node cluster, Scylla 6-node cluster, was able to process up to 125,000 operations per second, and we know that it can process more. Next slide is about pinger comparison. As Simon said, it's our health check tool which measure latencies from our clusters. You can see that from Scylla there is a few milliseconds, and Cassandra is going into hundreds. And a quick recap. After our test, we noticed that our node Cassandra node is able to do about 5,000 to 6,000 operations, while Scylla can process about 20 to 22 or more thousand operations per second. Of course, we can measure P99 latency, and you can see that speculative execution also is low in Cassandra. Okay, that's all about our test.
Thanks. After reviewing the results of the test, it became clear that we can safely replace a couple of Cassandra nodes with a single Scylla node. Based just on this one test, it was 40,000 requests when you had to shut down a test Cassandra cluster against 120,000 requests per second. And what's the most important here is the response time coming from the Scylla cluster under quite a load was much better. So 40,000 requests against 120,000 requests. That means that we can basically replace 3 Cassandra nodes with single Scylla nodes. If you look at it from our production cluster's point of view, 44 nodes can be replaced with 16 Cassandra nodes. So you would be saving a lot of money on hardware. And what's most important, our response time would be so much better. If you add to all of this the thing that, for example, repairs that we run basically every day take much less time, Scylla seems to be a perfect fit for our clusters. Well, everyone is saying that, but we'll say it anyway. We would like to ask you to do your own tests on your hardware, in your data center, with your data and data modeling to see how it performs. However, based on everything we've seen so far, we can recommend hardware reduction plan factor equals 2. That means that you can just slash in half the number of your Cassandra nodes and replace them with Scylla nodes. The things that you should remember, in our opinion, is, for example, hardware limitations. I'm talking about maximum, in our case, it was the maximum number of drives you can load into a single physical servers. The second thing is the minimum number of nodes in a cluster. It's basically defined by replication factor. For example, if we use replication factor 3, we need to have at least 4 nodes in a cluster to make sure that if one of them fails, we can safely get everything going.
Okay, and I would like to add some fact that we did a hardware reduction plan in our company. Now we have about 250 nodes, and we can lower this number to about 170 nodes in our production on our production servers. Okay, so what's next in Allegro? Scylla on production. We're waiting for some feature. For example, hint at handoff, what is expected in version 2.1. We use very often a time window-based compaction strategy. We also use, we have to use audit log. For now, we're not sure which way we go, but that's some case we need to have in Scylla. And the last one is lightweight transaction. But we think that in version 2.1 we will be ready to switch to Scylla. Okay, thank you for your attention.